Hello everybody and welcome. I just wanted to make this short video about the new multi-tab feature in Putty that you'll be utilizing in the topology for this lab. So once you've made your booking of the advanced KALI topology, if you click on them, there's nothing there. You can't get to it. So you actually got to go. So KALI is KALI. So if we click on PCA, that's KALI. That's just normal KALI. And the username is root. And the password is TOR. T-O-O-R. This is the root username and password backwards. Exactly the same as your normal KALI. So this is just classic KALI. Now if you go back to the topology, so you got R1, R2, and the switch, all console back to the PC. So if you go to the PC on the desktop, you'll see that there's this icon called Putty, and this is multi-tab Putty. This is a nice and easy little shortcut to show you how to use Putty to get all tabs. So that supports much. So we got COM3 is R1, COM4 is R2, and COM1 is a switch. COM2 is not being used because it's not there. So if we double click on this and press enter a few times, we've got a script running there just to pre-configure it to R1 just to help you out. And now that font's a bit small for my eyes, so I might just show you how to fix it. You right click on the tab and you can go change settings, and under appearance, and then the font, we say change. And I'm a big fan of Lucia Console 16. Apply. I'll make that full screen, see if that fixes it. There we go. Okay. So there you go, so that's R1. And now we go back over here, we just plus this out, we click on R2, and now it's a new tab. And it's got its own characteristics as well. But what I like to do is you can actually right click on this as well and say rename. So let's rename that to R1. Let's rename this to R2. And let's also change the font size so we can actually see what we're doing. Appearance, change, 16. What I might do just for fun is I'll actually change the background as well. We'll make this one a little bit blue, and I'll make this one a little bit green. And now the switch. So we double click on the switch. And there's the switch. Now this switch is a little bit more funky. So some of the security commands aren't the same as in your book. So best to have a bit of a fiddle with that. And also we found that when we were doing switch to switch, sometimes it didn't work unless we made it a trunk. I don't know. Just one of those caveats, because this isn't a legitimate, genuine Cisco switch. This is sort of a hybrid switch, so it's a bit not as straightforward. Oops, just lost my scroll, but that's annoying. So the others are there. Maybe I need to press. So here's our switch. So click on topology, and then we've got the KALI. 2 routers. So on PCB, there are 3 tabs. So this is router 1. Look at the interfaces. Whoops. Notice here that's only got gigabit interfaces. It's got 3 gigabit interfaces. So let's bring them all up. Let's see which ones come up. The diagram should say, shouldn't it? Oh yeah, there it does say. So gigabit 1 is for KALI, gigabit 2 is for 2, and gigabit 1 is that way, and then gigabit 2 is to the switch. And because I've already got host names, we're going to use one of my favorite commands. So gigabit 1 goes towards the KALI box. So goes towards router 2. Oops. And that's it. I'll back down again because we don't need it. Then we go to router 2. Give it 1. We go to the PC. And now what we might do is we might enable a simple routing protocol just to prove that everything works. So we'll do RIP because that's super duper simple. Back over to router 1. Router RIP network. And we always advertise the networks you own. Just the networks you own. And there we have it. So now RIP has learned about network 3. So let's give this guy a IP address as well, because he needs one. He's in network 3, 3.10, that'll do. Now I always need, because it's just a layer 2 device, we need to give it a default gateway. Now the default gateway is the router. Alright, so we're going to minimize this and give our PC an IP address because otherwise we can't do anything. So layer 4. For the switch 10, so we'll give this guy 50. It's a nice address. And the default gateway of the router again, 3.1. Now KALI, actually you guys can probably help me with this because I haven't done a lot of. Actually, I use the GUI because I know how to use the GUI. I don't know how to use the command line. Up here, there's this little funky joining thing, little sort of connection. So you go on wired, and then you go wired settings, and we want our network, and I click on the cog. Then we go IPv4. All right, it's already got an IP address. I don't like that IP address, so I'll change it. 50, but it's already got the gateway there. Now I think it's set to automatic, so it should be fine. So if we go apply and just check it, sometimes it doesn't take the first time. So even though it applies, so sometimes you have to actually just turn it off and turn it back on again. I don't know why. It's just a limitation of KALI, I guess. Oops. Wired connect. Okay, there we go. So now it's 192.168.1.50, which is what we want. So let's just prove that it works. Yep, perfect. 1.1. Make sure we can ping our default gateway. And we can. What do we make the PC? 3.50, I think. And there we go. So now we're pinging from this PC. So KALI all the way through the other PC. And just for fun, we'll check the switch. What do we make? Oh, do we make the switch 10 or 20? I can't remember. It's a bit embarrassing. What do we make the switch? Come on. Oh, I made it 10. Silly me. That's why it's never going to work. My 10 should work. 192.168.3.10. Troubleshoot that switch. Why doesn't that switch work? Oops. There we go. Let's learn how to type. Yeah. Do I switch it to 3.1? That's right. That's right. Let's see if we can ping the router. Okay, see what's going on here. So we can see the gateway, we can see the PC. Oh, let's check PC to PC. Maybe that's a bit more of a more sensible test. See the PowerShell. Sorry, fix that yet. Make that font bigger. The PC can definitely ping it. So why can't the switch? Right, let's see if R2 can ping it. R1. Okay, must be something wrong with the switch. Done something to the switch. I busted something out. Let's have a look. Yeah, it shouldn't be a trunk, but I don't know why. I'll make that not a trunk. Which is 1 again. Zero, 1. Yeah, that faces the switch. I'll make it. Let's just do this just to make sure. Best video ever. Just have to edit all of this out. Here's a permanent. That's a pretty cool setting just to see get permanent pings. Actually, I'll move this down here so I can see it. All right. Oh, that didn't break it. David set this up, so there was a weird bug, he couldn't get it to work. So now I've sent them all back to default. So I go back to KALI. Maybe there's a bug with the switch, alright, so that's going to be a bit of fun. We can't make the switch do switchy things. It's definitely 3.10, isn't it? I'm not just going crazy. Yeah, 3.10. In the PC, ping. Yeah, so it gets to the router. So it gets to router 2, and then it doesn't go any further. So let's have a look at router 2 just to make sure we're not just. See, router 2 can see it. Okay, why don't we do this? Let's bring down that interface and bring it back up again. Sometimes showrun is not always the best. We should stop. Hope. There we go. See if it comes back. There you go. There's a good destination reports host unreachable because notice how it's coming from itself, 3.50. Saying, oh, there you go. Network's again. All right. Okay, the switch is doing something weird. That's all right. We'll burn that bridge when we come to it. I don't know. I'll troubleshoot that offline. Everything else works. KALI can print. So the PC to PC. All right. So the switch. Yeah. So there is a definite limitation with this version of NetLab because that switch is a virtual switch. It has a few little funky idiosyncrasies. So we'll have to. Work that into the. This is 150. I wonder if I can ping from the switch to 150. Oh, I know what it is. I just remembered. I'm an idiot. This switch isn't a real switch. That's what it is. Where is it? Let me see. There's a command here. This switch is actually a router pretending to be a switch. Yep. So it's not IP default gateway. It's IP route. It's a router pretending to be a switch. Yeah. All right. So that's just a bug with this. But in the real world, you shouldn't have to do that. But we'll put a little note in the in AT4. Let me make a note of that now before I forget. AT4 S1 IP route 0000000. X. All right. Okay. Well, there you go. I got it to work. So I'm happy now. Still, it's out the CDP notice doesn't work, but never mind. So that's something a bit weird because technically a real switch is a layer 2 device, so it wants the default gateway. But because this isn't a real switch, this is a router pretending to be a switch. Therefore, we've had to use the routing command, which is IP route. So IP route 0000000 means everything. So every possible IP address route via the default gateway. So apologize for that. It's just one of those funky little things. You can see how CDP neighbors doesn't work, but never mind. Oh, now it's gone down. Maybe it doesn't like the trunk. Maybe that's what. All right, let's do that then. All right. Oh, no, it's coming back in. Let's check the route table. Oh no, that's come back in. All right, I don't know what happened there. Remember we talked about duplex before? When you're just showing it for status, that's how you see the speed on the duplex. So everything's on auto. Only port 1 and 2 are connected. And on a router, it's just show interface. And there we have up the top here, full duplex and a gig. And it's automatic. So it's automatically figured that out. So remember, show interface is layer 2, show IP interface is layer 3. Oops. So show gigabit 0. No, it's not 0, it's 1. So these are all the stattings. These are all the stats. We've got MTU, we've got a 5-bit input rate. These are all layer 1 and layer 2 information. Bits and bobs and numbers and stuff, all that sort of awesome stuff for troubleshooting layer 1 and 2. But if we do show IP interface, that's where we get layer 3 information. We've got our IP address, we've got our broadcast. We've got all of these lovely things that you guys don't need to know about yet, but they're all layer 3 things, and you learn a little bit more about them. You learn about some of them in 991, but that's about it. But not in this switch. So just for fun, just while I'm doing this lab, because I'm recording it, and I'll go back and re-edit it maybe I'll just upload it with all my mistakes in it. It'd be a bit of fun. Bit disappointed that that's there though. Can't get rid of that. Maybe I'll go full screen and then minimize it again. Okay, so here's our route table, and we're currently running RIP. So why don't we just migrate this to static routes, because you guys need to learn about how to do static routes as well. So that's what RIP has learned. So let's change it to a static route. So it's IP space route, destination network, which is 192.168.3.0. It's a /24, so 245.2.5.2.5.0. And how's it getting there? 192.168.2.2. Now, we can put some more stuff on the end. We can put an administrative distance, we can put a name, we can put a tag, we can put a track, we can do all that sort of stuff. But just for the sake of the day, we'll just press enter. Now, our pings should have kept working, and they have, because we haven't changed anything. But now, oops, now, show IP route, and now our RIP entry has been replaced with this static route. So let's get rid of RIP altogether to make sure that's definitely not doing it. No route to RIP. In a few seconds, this ping is going to die, because router 2, well, let's check. Let's see what's happening on router 2. So show IP route. Okay. This is 23 seconds old. Let's just show IP route RIP, and we'll watch that RIP die. It's a bit of fun. We'll do this. Yeah, actually. We'll do this. We'll do it a bit cleaner. Code 192.168.1.0. See if this works. Okay, good. So, because RIP should update every 30 seconds, so that timer, this number here versus 57, that should never go above should never go above 29. But in a minute, we are going to see that this route is going to be. So as you can see, the time is growing and growing and growing. But once it reaches 180 seconds, RIP will say that this network is no good, and it will try and flush it out of the table. And at that point, the pings will stop working. Ah, there we go. Now, notice here that now RIP is freaking out. And it says, because 180 seconds have gone past. So it says, this network's, so it's only going to wait another 30 seconds, because 180 is markers down, and then 240 is completely chucking in the bin. I'm going to chat again. All right, people are chatting to me. All right, this should be gone by now. Oh, there you go. See, now the ping just died, and now it's completely gone from the route table. So let's fix it. So IP space route. Now, where was it? It was 192.168.1.0. That's the destination network. Now 245.2.5.2.5.0 is the mask, because that's the /24. 8 plus 8 plus 8 plus 8 is 24. And this has to get there via the other end, the other IP address. So 192.168.2.1. That's the other address of. In fact, you know, let's just today. Let's do this. Let's put a question mark here. So look at all the options we've got for routing. So many different options. So just for fun, we'll be lazy, and we'll say, okay, it used to get there via gigabit 1. So let's just type in gigabit 1. Now this is inefficient and a bit messy, but it works. Because basically we're just saying, oh, that network's over there, out that interface, go figure it out. So yes, it works, but it could be better. So in fact, the ultimate is to have both the interface. Oh, hang on, before I do that, let's just verify the route table. Now, if you're feeling lazy like me and you don't want to exit out of the global config, you type the word do, and it's as good as exiting out. All right, I'll be interested to see if this changes. I haven't done this in a while. See, it says 192. Oh, I'm pointing at the screen with my finger. That's no help. 192.1 is directly connected to gigabit 1. That's the static route. But let's put this command in there, and let's actually put the IP address in at the other end. So this is the IP address of the far end. And now it's given a much more precise. Actually, maybe that's just a bug. Let's just make sure it doesn't do it twice. That'd be embarrassing. Yeah, it has done it twice. Silly thing. So we've got to get rid of that other one. It's meant that when you do a command that's the same, it's meant to override it. So, Control A takes me to the start of the line. So I can just type the word no and press space. No, it's the same. Okay, well, there you go. Yeah. Oh, what happened there? Did I get rid of the wrong one? What a dope. Silly Josh. The wrong one. Sorry. I got to that one by mistake, like an idiot. So we want this one. Well, Control A, start of the line. We want this one. Control A, and then Control E for end of the line. We want to get rid of this one. That's the one we want to get rid of. There. Notice now that it says static route for S. The destination network. See, it's a network because it's an IP address and a mask. Network, two things. It is via this IP address, and this IP address is reachable via this interface. Later on in your network journey, you're going to learn that there are more efficient ways of doing things, and this is one of those ways. The most efficient way you can set up routing is pointing it to both the exit interface and the IP address. So the router doesn't have to think. The router doesn't have to think at all, and that's it. All right, I'm going to keep recording this and make this video way too long, just for fun. Let's put IPv6 on this bad boy, just for fun. So, I know you guys love IPv6, and I love it too. So this is now the second half of this video is IPv6. Let's cheat. So we go interface gigabit 1. That's the PC, right? So we'll just copy. Sorry, I'm pointing at the screen. This doesn't help you, does it? We'll just copy the IP address. So IPv6 address 2001 cafe. They like cafe ODB for some reason. I don't know why. Just maybe it's a bit of fun. What's ODB? No. We'll just do cafe. I'm feeling lazy. Actually, no, we need 3 things. Cafe, A, B, C, D, and we'll do 1. This is we'll use what remember I've said this a couple of times when you're subnetting. When you're doing subnetting with IPv6, 99 times out of 100, this 4th block will always be empty. So that's the one you play with. And if you don't set the link local, you'll get some rando nonsense thing, which is really annoying. So let's set it. $1 link. Okay, that's done. Now we also need a static route as well, don't we? Actually, just for fun, shall we do yeah, we'll do a static route first. Why not? IPv6 route. I'm just getting ahead of myself here. IPv6 route. We got 2001 cafe A, B, C, D. Now we to be able to find 3. So that's the network we're going to need to be able to find. So 3, because that's a network, remember? And that's going to be reachable via the other end. Let's see what there it is there, the address. So now we're going to set R2 in a second, but I know that we're going to set it to FE80:2. No, it doesn't like. Oops. 80:2. Interface. Oh, okay. Gigabit 2. Okay, that does not like. Okay, gigabit 2, FE80:2. Okay, so now we've told it in advance that that the 3rd network is going to be 3. So let's actually configure this up. So we want interface gigabit 1 is going to be IPv6 address 2001. God, I've forgotten the way around. I did it now. It's dumb, isn't it? That's why documentation is so important. Cafe ABCD. Cafe ABCD. Oops. ABCD. Now the link. Oh, hang on, did I even set that? No, I didn't, did I? Completely forgot. What an idiot. We haven't finished over here yet, have we? Oh, we forgot all about it. What a dope. 2. You can just keep spamming the up arrow until we get something we like the look of. Back to R2. So this is 2:2:2 /4. And we need the IPv6 FE80:2 for the link local. Because the FE, remember, the link local is for like the ARP replacement. So you've got to have the real address, the legit address, and how it's going to do all of its ARPing magic, all of that, sort of that multicast stuff. So we give it a link local address as well. So that's 1. So that's the link now between R1 and R2. So now we've got to do the 3rd network, which is 3. So use your up arrow. Oh, this can be 1 again because it's the default gateway. Now remember, the link local addresses can be repeated because they only matter for the interface they're on, because they're only really used for layer 2 magics. Let's fix that first. It's driving me nuts. Fine, console 0, logging synchronous. Now, when it does it, I get the prompt back. Show IPv6 interface brief. Okay, so, and there. Oh, what happened? I forgot. Oh, I'm an idiot. Why didn't anyone tell me in the chat? Show run. I did it on the wrong interface, so I'm a dope. Two is meant to have all these magical commands. Yeah. So this I'll just type it. Okay. So IPv6 route, probably a more useful command. Okay, so there we go. We have the 2 is facing that way, and the 3 is facing that way. So now, oh, there's no route yet. We haven't set a route back. So IPv6 route to cafe E. So we need to tell router 2 how to get to network 1, because that's the one that's far away. So 1.64 is going to be via gigabit 1 and FE80. All right, so let's see if that works. First of all, we need to go to our PC and set up IPv6. Now, if we're lucky, it may have already done it auto-magically. Let's see if it has. You know how IPv6 uses Slack? So, PC. Oops, this one. No, it hasn't. Okay, so maybe it's not even enabled. Let's enable it. Please. IPv6. Actually, it should have got one automatically. You know, let's try and trick it into getting one automatically. So we'll disable it, just like, you know, unplugging it and plugging it back in again. Obviously, our pings have failed. Come on. See if that works. Oh, maybe because we set IPv4 statically. I think that might have broken it. That's all right. I'll just delete this bit out of the video because it's a bit silly. We'll just say we set it manually anyway. Come on. No, I think I busted it. All right. Yeah, because you can't get IPv6. No. All right. So we set it manually, which is probably what we should do anyway. So properties, IPv6, because that's what we want to change. All right. 2001, cafe, ABCD. Now this is what I want. PC what? B says network 3. And we'll call it 50. Make it easy to find. Now this is the weird thing is, remember this is that FE80, because this is now if we didn't set this, the link local would be some random super long address and really annoying. So that's why we've done it that way. So let's go back to Putty and ping 2001. Oops, ping 2001 cafe ABCD oops 3:50. Is this going to work or not? Alright, so let's see what we've done wrong. Maybe I typed it wrong. Oh, I know what I did wrong. Why did you all tell me in the chat? I've forgotten something super important because I'm an idiot. If you want IPv6 to work at all, you must turn it on. IPv6. You gotta turn it on. IPv6 doesn't work unless you turn it on. So let's turn it on my one as well, because it's never going to work unless we do that. IPv6 unicast routing. Let's just get it from here. Let's see. That's going on, isn't it? I'll fix it up here too. Yeah, logging synchronous. It gets rid of that stupid character term. Very useful command. Cafe ABCD 3:50. Haha, killing it. And this is from R1, remember, not from R2. So this is going through R2 to get to that PC. Alright, sorry about this, but it looks like my microphone, my MS Teams just got muted for some reason. I'm not sure why, but I'll keep on going regardless. So what I just wanted to show you here was the show IPv6 neighbors command. Now, just like show ARP shows you MAC addresses to IP address and IPv4, show IPv6 neighbors shows you the similar sort of information you need in IPv6. So you can see there's all the IPv6 addresses we've learned and discovered from this PC. Notice too that we have the Slack address that we gave ourselves magically, and also our link local address, the big long address. So I'm kind of glad we didn't have to type that. So that's why you give yourself a static address, because it's just a lot less typing. So just a final verification, we're going to ping the router just to make sure that the router is happy. And we've got full connectivity from our PC to both routers. So we're going to make sure that works properly. And it does. And then next we are going to set up a ping to 1.50, which is going to be the KALI box. And we're going to just leave that ping going, and then we're going to flick over to the KALI and give the KALI an IPv6 address. So show ARP for IPv4, show IPv6 neighbors for IPv6. Pretty cool. All right, so we log into the KALI box and we stop that IPv4 ping. We go into the network settings, and then we go into the wired settings, and then we go into the cog for settings, and we click on the IPv6 tab, and we've got a whole bunch of options there. Slack may have worked with automatic, but we want to do it manually because we want to know how to type the easy number. So we click on manual, then we type 2001 cafe ABCD 150, because that's the address we've got in our documentation. Prefix is always 64 because that's the default prefix for everything, and the gateway is the link local address. As you saw on the previous screen, we could have had a big long address, but we don't want a huge long address, so we just use FE80:1, and that's a more palatable and much easier to type. Now, for some reason, it didn't accept straight away. I think that's a feature of KALI, that when you make changes on your LAN card, it doesn't stick immediately. So triple check, it looks right. So when all else fails, turn it off and turn it back on again, but what we're going to do is just going to unplug the cable. So the quickest way to unplug the cable is up in the top right hand corner, you got the icon. We go to wired connections, we say turn off. Right, disable the interface. And we go back in and we click on the wired and we say connect. And almost instantly, those pings start working. So now we've got full connectivity from IPv4 and IPv6 running on the same equipment. And it's right about now that people in the chat have noticed that my microphone is working. And they're talking to me and I'm apologizing and I've turned on my microphone. So now we'll get back to the original audio. So you'll hear my bad overdubbing. But there you go. So now I've done IPv6. So, yeah, so this video is already about a third of Assessment Task 4. Just programming. I mean, obviously I haven't done passwords. I haven't done no IP domain lookup. I haven't enabled SSH. But I've set up IPv4, I've set up static routes, and I've set up, let's do a show run and let's get the interesting things. So, that, critical. Look at our two interfaces. So, all right, so IPv4, straight up. IPv6, remember you don't have to set the link local. But if I didn't set the link local, if I did not set the link local, at this point, I would have had to type in that whole thing. FE80, I would have had to type in that huge long, I would have had to type in a huge long address and it would have been a nightmare. So that's why I'm a big fan of setting the link local and it's easy to type. So you don't have to worry about it. And because it only lives, link local addresses only live on the layer 2 segment. If a router's got 20 interfaces, all 20 link local addresses can be the same because they never leave. The link local is just to get around that ARP broadcasting magics. And so, well, this one's still got RIP, but these two commands, in fact, I'll prove it. Let's get RIP all together. So these are the two static routes. So this static route is to make IPv4 work, because remember it's the other side. So 192.168.1 is way far away. Oh, how do we get there? Oh, we go out this interface, heading towards this IP address. Exactly the same for IPv6. I just cheated and I used 192.168.1 and I put a 1 there. So that's just me being lazy. But literally with IPv6, that's all you need to do. You're only ever going to get 2 or 3 blocks. And even if you're given this block, it's always going to be like something 00 or something 0. So you've still got the far right hand side to make up as many VLANs as you want. Sorry, as many subnets as you want. So IP route, destination network, exit interface, next hop IP. IP route v6, destination network mask, exit interface, next hop IPv6 address. Alrighty, I might stop recording this now because this is a good setup. Pretty sure that's, yeah, cool. But yeah, so like I say, this is the sort of complexity for Assessment Task 4.
So, thanks for watching. Please remember to subscribe, click the notification bell. If you enjoyed this video, give me a thumbs up and leave me a comment with what you'd like me to make for my next video. I'll see you in the next one.